question, we are given that exactly 3 seconds after a projectile is fired into the air, it is observed that its velocity is this. So it's given an I and j components, uh, where the x is horizontal and y is positive upward. Okay. So what is the horizontal range of the projectile? Okay. So let's say it is fired from here and travels like this, and after some time its velocity, let's say over here, is given as 8.6 I, which means that 8.6 is towards the x-axis, and 4.8 j, so 4.8 is towards the y-axis. Definitely the horizontal velocity is going to remain the same in a projectile because there is no acceleration in that direction. So we can say that the initial horizontal speed is going to be 8.6 meter per second. The initial vertical velocity is something which is unknown to us. Let's call it v. Acceleration due to gravity is downwards and the time taken is 3 seconds. So we can use the first equation of motion, which says that v is equal to v naught plus at. V is the final velocity, which is 4.8. Initial velocity is considered as v. Acceleration due to gravity is g, which is downwards, so minus 9.8, and time is 3 seconds. So from here, the value of v comes out as 9.8 times 3 and plus 4.8. It's coming as 34.2. So 34.2 meter per second is the initial vertical velocity. Let's call this Vy. So this is the initial vertical velocity of the projectile, and we are interested in part A as the horizontal range of the projectile. So horizontal range is given by v naught square sine 2 theta over g. So this is the formula which will enable us to get the range, the horizontal range of the projectile, where v naught is the initial velocity, the net initial velocity of the complete flight. So this is v naught, and theta is this one, so we need to find this angle as well. So let's work for both. V naught will be given as square root of 8.6 square plus Vy square. So that's going to be square root of 8.6 square plus 34.2 square. So this is going to be same as 34.2 square plus 8.6 square, and square root of this is 35.26 meter per second. This is v naught. And if we talk about theta, then tan theta is the vertical velocity over the horizontal velocity, which is 8.6. So theta is going to be tan inverse. Uh, the vertical velocity is 34.2 over the horizontal velocity, which is 8.6. So let me grab my calculator again. 34.2 over 8.6, and tan inverse of this is coming as 75.88. This is coming as 75.88 degrees. This is the angle of launch. So the range is going to be, we are going to plug in everything. So the range is going to be v naught square, that is 35.26 square, sine uh, 2 theta, so 2 times 75.88, 75.88 over g, which is 9.8. So let me grab my calculator again and get this solved. So this comes out as 35.26 square times sine of 2 times 75.88 over 9.8. So this is the range, which is coming as 60.03 meters. So this is the required range, which answers part A. Part B is the maximum height and speed and the angle of motion just before it hits the ground. So maximum height, again, we have a direct formula, which is v naught square sine square theta over 2g. This is the maximum height. We know everything, just plug in the value. So 35.26 square sine square 75.88 over 2 times g, which is 9.8. So this is going to be same as, let me grab my calculator, sine of 75.88 square of this times 35.26 square over 2 over 9.8. So this is 59. This is 59.66 meters. This is the maximum height. And the last part is the at the time of hitting the ground, what is the angle and the speed. So speed is going to remain the same as the initial one. So speed will be same as 35.26 meter per second. The only thing is the angle. So the angle is going to be symmetric. If it's getting launched at an angle of theta, then at the time of hitting all as well, it will have an angle of theta only. So at the speed and the angle of motion just before it hits the ground is the speed is this, and the angle is gonna be same as 75.88 degrees with respect to the ground. Thank you.